welcome to this coding challenge. So we're gonna do string methods, which again are probably the most difficult part of strings, are understanding how to use string methods. It looks like we're gonna create 10 total functions, starting from count letters to add exclamation. Go ahead and add these to your general functions folders. Um, so we're just gonna start right into it. Um, so the idea here is how we're gonna create a function for every code challenge that we're given, right? So here, let's look at this first one. I'm gonna reset so we don't cheat. Okay, so we're gonna write a function called uh, unique English letters. Okay, cool. Unique English letters. Sorry, I'm just reading the. Okay, cool. So write a function called unique English letters that takes a string word as a parameter. So here are our tests, right? To test our function. And what we're gonna do is we're gonna get right into it. We're gonna write our function. So and it takes a parameter word, it looks like. The function should return the total number of unique letters in the string. Uppercase and lowercase letters should be counted as different letters. We've given you a list of every uppercase and lowercase letter in the English alphabet. It will be helpful to include that list in your function. So I think what they want us to do is check against letters. I don't think we need to though, right? Um, hmm. Well, here, let's write it this way. So let's create a new um, we'll call it list. New list. Okay, and then let's iterate over each data that's going to be in Word. And then if the data in new list continue, else new list dot append data. Okay, cool. So let's talk about this. So I said if the data, okay, is in new list. So instead of checking against this index of every alphabet letter that exists, what I'm going to do is I'm going to say create a new list, and then for every data or every character that's in that word, okay, if the data is already in the new list, then skip it, right? Otherwise, go ahead and into that new list put our data, okay? And then at the end, what we're going to do is the function should return the total number of unique letters in the string. So we're not actually returning the letters. It looks like we're returning, and this will be out of the for loop. So it looks like we're going to return the length of whatever new list is. Okay, and so let's take our test off and let's run it. And we get 4, and it should print 4. And then let's do this. Let's run this. 4 should print 4. So that was a pretty easy one. Again, they tried to give us this list of alphabets so that way we would check um, each letter against it, right? And then what you could do is you could remove that letter from the list. And then if that letter's not in the list, then it's already in the word. But why not just create a new list? They're not asking for us to return each unique letter. They're asking us to return the number of unique letters. So it's just easier to find a unique letter and pump it into new list. So if we look with Mississippi, what we should do is we should enter a capital M. And if you see the capital M, because it's uppercase, it gets added to the list here, 5. If I take away that capital M, it'll run and it'll still take the lowercase. So this is probably a different way than they wanted us to do this, but that's fine. We completed it, no problem. All right, moving on to the next one. Count x. All right. So write a function called count char x that takes a string named word and a single character named x. Okay. Let's see what they want us to do with this. The function should return the number of times x appears in the word. So right away, what I'm going to do is I'm going to create a counter. That's going to count how many times a word appears. And what I'm going to do is I'm going to iterate over each letter in the word. And I'm going to say if the letter happens to be equal to x, then just add 1 to the count. And then when I'm done with everything, just return the count. Okay, so let's uncomment our test. These are actually pretty easy ones. We're probably going to get some harder ones coming up here. Ooh, 4. I why put in there? 4 and 1 should return 4, should return 1. So these are our tests. Here's our function, and it works just fine. These ones aren't bad. All right, let's take a look at this next one. Let's count multi-character x. Okay. Write a function named. All right, so count multi-char x. It takes a string named word and a string named x. So our function's already set up for us. This function should do the same thing as count char x, the function you just wrote. It should return the number of times x appears in word. However, this time, make sure your function works when x is multiple characters long. For example, count multiple characters, Mississippi, looking for ISS should return 2 because there's 2 ISS's in it, right? There's the first ISS, and here's the second ISS. Okay, so let's sort of do the same thing we did before. Let's create a word count, but we know that we're going to call it a letter count instead of a word count. That's what we're going to do, okay? And it's going to be equal to our word, right? And we're going to split it wherever we find x, right? So in this case, x was ISS. So it's going to find ISS and it's going to split it. And it'll get rid of the ISS's, but it'll create a list of items, right? And that list of items in this case will be M and then IPPI. So the length of the list will be 2, right? So that's what we're trying to do here. We're going to return the length, okay, of our letter count, okay, -1. Let's print our test. Let's run it. 2 and 1, cool. So, and the reason why we're doing -1 here is because the letter count will split. So say we have, okay, so look at this word here, apple. We want to split it on the double P's, right? This will give us a list that consists of 2 things, right? If we subtract 1 from that list, apple, right? Then we know that PP has only appeared once. So if you look at ISS, right? ISS appears twice, right? So this gets split twice. The first time it gets split, the first time Mississippi gets split, you get an M. The second time it gets split, you get a blank space, and you get the remainder, which is PPI, right? So you're going to have a list that looks like this when you split them. when you split Mississippi by ISSI. Okay? The reason we're subtracting 1 is because if you always subtract 1 to find out how many times the splits are working. Every time it gets split, even if they're right next to each other, they'll create this empty space. So the formula is just subtract 1. If, for example, in Mississippi, right, we added up another ISS, IPPI, and we were to run, it would go up to 3. And the reason it would go up to 3 is because there'd be another blank space. F12, oops. Okay, Mississippi will be ISS right here, which is what I just put in, IPPI. So we'll get, what'll happen is we'll get another PPI, essentially. So we'll have 4 things, which if we have 4 splits, it means we only have 3 ISSs inside of the word. That's how we ended up with that. Okay, so we're going to do the substring function next, and this one was a little bit more tricky. So, and I'll show you why in a second, because this is why like unit testing is incredibly important. So it says we're gonna create a function called substring between letters, and it's going to take 3 parameters. The first parameter is going to be word. The second one's going to be a start, which is a starting character. And the last parameter will be end, which is an ending character. Okay? Alright. So this function should return the substring between the first occurrence of start and end in the word. So between where start and end are, we need to grab all the letters in between. So if you look at this example, they give us apple. They want between the P and the E, which is the starting character, the P and the E, right? They want us to grab PL, pretty much, and return that back. Okay? If the start or end are not in word, the function should return word. So the first thing we can do is we can start off with a condition that gets rid of this immediately. That says if the starting character or start is not in word, okay, or the end character is not in word, okay, then we can just return word. That's it. Okay, that's all we can do. So else, I'm gonna do things a little bit different here. So I'll show you 2 ways to do this, right? So the first way to do this is pretty simple. The first way is we're going to say word. In word, we're going to return word indexed at word.findStart. Okay, and we're going to add 1. And the reason we're adding 1 is because remember when we talked about splices, we said left was inclusive and right was exclusive. Well, in our requirements, they want both left and right to be exclusive. So in order for that to happen, we have to add 1 index, which will shift where our index starts by 1 to the right. So we're going to find the starting character, and then we're going to shift right of that starting character by 1. Okay? And then we're going to word.find, and then we're going to find the end character, so to speak. So if we actually run these tests that they give us here, yay, our test passed everything, right? Wrong. Because think about it, okay? We're word.find end, and we're putting in the letter E. What if the letter E came before the starting character? Okay, so let's write a test for that. Let's print out a substring between letters. Okay, and let's put in Easter. Okay, and let's say we want to get between the A and the E, right? Between the A and the E, we want ST to print out. So let's run this and see what happens. Nothing comes out. And the reason why nothing comes out is because this is out of range. So this passed the requirements, but this is where like the QA and the BA need to get together and refine the requirements and say, okay, we can't just find the end character. We have to find the end character from the beginning of the start character. And let me show you how we do that. First, let's get rid of this statement. Because remember, our second unit test, our third unit test down here, failed because E comes before A. So it never returns. It comes inside of here and doesn't return anything. It just blows up. It all goes to nothing. Okay? So we want to be good programmers, and to be good programmers, we need to figure out better ways to do this. Okay? And the better way to do this is we're gonna create a starting index position. Okay? And the starting index is going to be our word find start plus 1. And this is going to give us back a number. Okay? And then we're going to slice. Okay? We're going to create our first slice. And we're going to take the word. Okay? And we're going to index it at the start index, which we just created, which is just a number. Remember, this is just going to come back with a number. Okay? And then we're going to start but at that start index, and we're going to slice that word to the end. So we're going to start at our starting character, and we're going to go to the end of the word. We're going to grab all that, we're going to save it into the variable slice1. Okay? Then we're going to create an end index. Okay? And what that's going to do is that's going to take slice1. Okay? And we're going to find end within that slice. Okay, that's what we're going to do. And that's going to come back with a number. And we're going to say this is going to be equal to... So what's interesting here is... What I think actually has to happen here is... Remember, we have a starting index, which is a number. Now, that number we have to add to this position to include the other slice. So what I mean by that is, if we have the word Easter, okay, if you look at our requirements, we're going to start at A, which means we're splicing, or slicing, I should say, off the E. Okay? Now the E, and let's visualize this so it's not confusing, is at index 0. We're starting at index 1. So let's go here. Okay? So we're starting at, so if Easter, this is index 1, 2, 3, 4. 1, 2, 3, 4, 5. Right? These are the indices, so to speak. And do we could probably use pipes to show you this. It might be better, more visual. Okay, so these indexes all belong to Easter. Okay, so this is Easter, okay? This is Easter indexes. Okay? However, we created a new variable called the slice1, which slice1 is A S T E R. Okay? And the indexes for those are 0, 1, 2, 3, 4. So slice1 has 4 indexes, and Easter has 5 indexes. Okay? And what we're doing in this logic is we're saying the end slice is we want to find the end character. In Easter's case, the end character is E within this index. So this is slice 1. So in slice 1, let's find the E. And here it's index 3. Okay? But if you look, right, in Easter, E is in index 4. Well, what happens is wherever our starting character is, in this case A, whatever indice that it belongs to, which in this case in Easter belongs to 1, you have to add this indice, right? So indice 1 to the indice 3 in order to find where the E's position is back within Easter. Okay? So that is a little bit confusing, but you can see me at IC Stars. We can go into this a lot further if we need to. Okay. So we're going to add the start index back into it, and then we're going to return, okay, we're going to return the word from the start index, okay, sliced until the end index, okay, and then we're going to rerun our test. And look at that, it comes back with ST this time instead of nothing. Why is that there? Oh, come on. Let's try that again. Hey! Okay, so I know that's kind of confusing, and I had to use a whiteboard to solve that one. It's not easy. And these unit tests, again, they did not take into consideration the Easter, right? Use cases where the last letter could possibly come before the first letter. So again, these are tricky, but that's why we're developers. That's why we're coders. We're here to figure out those problems. Okay, let's move on to number 6. So number 6 is called X length. Okay, so let's read the instructions. Let's create a function called X length words, and it looks like it takes a sentence. Ooh, fancy. Takes a string named sentence and an integer named X. Okay. This function should return true if every word in sentence has a length greater than or equal to 0 or equal to X. So if every word in the sentence has a length greater to or equal to X. Okay. Sort of a weird requirement. I'm fine. That's fine. Okay. So the first thing I'm going to do is I'm going to create a new variable, and I'm just going to call it lines equal to, and I'm going to take that sentence and I'm going to split it on all the white spaces. Now this should give me a list of words within the sentence that I'm going to iterate over for line in lines. Okay. So we're going to say if the length of line, which is each, so these are really words. So I'm going to change this to word for word in lines because we're really looking at words. We're not looking at a line. If the length of the word, okay, is less than X, okay, then, yeah, so return false because it's the opposite of true. And then otherwise, we're going to return true. Okay, so if the length of the word is less than X, then we're going to return false, right? Because that would then mean that the length of the word is greater than X. And here our requirement says that this function should return true only if every word in the sentence has a length greater than or equal to X. So if the word is greater than X, it should return true. So the negation, or the opposite of that, is if the word is less than X, the length of the word is less than x, then we should return false. Otherwise, it's greater than. We should return true. So let's go ahead and look at our test cases, and should print false true. We get false true. Easy peasy, lemon squeezy. Let's move on to the next one, reset it. All right, check for names. Okay, write a function called check for name, and it takes two strings, and the two strings are sentence and name, it looks like. The function should return true if the name appears in the sentence in all lowercase, all uppercase letters, or with any mix of upper and lowercase letters. The function should otherwise return false. So this is a give me. So this is a trick. This when I first started programming in PowerShell, I learned this, and the first time I had to deal with Linux, I learned this. So I'm going to create a variable called the name checker. Okay, and what it's going to do is it's going to take all the names and it's going to lowercase them. Okay, name check is equal to name.lower in the sentence dot lower. So it's gonna essentially what this is doing is it's converting everything to lowercase and is saying, okay, is the name dot lower in the sentence dot lower? Is this name within this sentence? If it is, name check will be true or false. So if name check is equal to true, return true, else return false. And there might be a better way to do this. This seems like a really sort of dramatically long way to do this. Let's look at our unit test, make sure. So it should be true should be our unit test, and it is true. There may be a better way to do this, maybe in one line, maybe just return return name check if name check is true. So I wonder if we can just like one line it like this. return return that statement. Wow, so we can bring it down to one line. Look at that refactor, dude. Yeah, wow. Okay. Awesome. One line of code from the 4 that I wrote. All right. I will take it. Okay, let's look at the next one. Every other letter. Okay. So create a function named every other letter. Let's reset this first. Create a function named every other letter that takes a string named word as parameter of the function to return a string containing every other letter in the word. So we did this before, and if you saw before I reset it, it looks really short, and that's because this is a well-known sort of technique by now, like we've practiced. If you want to return every other letter in a word, okay, you're going to return the word, okay, and you're going to double slice it, and you hit 2, and the second tells you to return. So the two empty colons represent everything. So actually, if you get rid of the 2, okay, and we just do a print statement and we run it, it returns the full word. That's what the colons is there for, the double colons. This is from 0 to something, 0, anything, infinity, to the end of the word. So if I put a 2 at the end, the 2 now represents what I can skip by. Remember how we did that? So if I did 1 and 3 and I hit run, that's probably bad. We should probably do 0 to 3. It will start at 0. It'll grab the C. It will then skip 2 positions, 1, 2, grab the D. Oh, actually 4 positions here, right? It'll skip 1, 2, 3, 4, 5, 6 positions and grab the D. Why? Let's do that. Oh, it grabs from 0 to 3, and then it slices off the remaining end of it. So if I put the 2 there, it'll just it'll skip. So it'll go from 0 to 3 by 2s. So if I do 7 here, it'll go from 0, index 0 to 7, which is here. 1, 2, 3, 4, 5, 6, 7. It'll grab every second letter. So C, D, C, D. However, if I put an empty and an empty, it'll take the whole word and just give me every second letter. If I did this, it'll give me every third letter. So that's a cool little formula that you can use, and works every time. That's a quick one. That was a give me. All right. So reverse string. Oh boy. Let's take a look. So write a function named reverse string. I already know what they want us to do on this one. Reverse string that has, because it's called reverse string, has a string name word as a parameter, and the function should return the word in reverse. Okay, so let's think about this. Let's create let's create a new word, and let's not put anything in it. It's going to be empty. Okay. Then what we're going to do is we need to loop through each character in Word. Okay. So for I in, remember index. This could be index. Remember index. Or for I in range. Okay. So we have a range. The range is going to be the length of the word. Okay. Right now, if you look at our test, the length of the word Codecademy is what, 7, 8, 9, 10. So this is 10 letters. So the length of Codecademy would be 10. But it only has, the indexes are from 0 to 9, not 0 to 10. So we know the first thing we have to do is subtract 1, right? Because if you go to the 10th index, the 10th index would be out of range. Because if we do that little thing where we go, okay, here's, code, and then I'm just going to put a dot, 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 and let's go to Y, right? Then this would be 0, 1, 2, dot, 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 get to the very last one, and this would be 9, not 10. Even though the length of the word is 10, in order to get the index, we always have to subtract by 1, okay? So, when we're doing ranges have 3 parameters. Where we start, right? The from where we start to where we end, right? So we're going to start at the range of the length of word, which is 0 through 9. So we're going to start at 0, okay? And we're going to start at the -1 index on this. And remember what the -1 index was. It would be the last character. So we're actually going to start by putting the -1 next to this. This -1 gives us the index 9, the first index -1. The second -1 tells the code to count down, okay, or to start, not count down, but to start at 9, because this is the -1 index. Okay, so if we took Codecademy, and we can test this right now by commenting that out, deleting this. We took Codecademy as a string. My word equals, right? And then we print it out. Okay. My word, or no, that's useless. The range. Paste it down here. The range of the length of, instead of word, right? My word, and we ran that. We're missing a parentheses, it looks like. Hold on. 1, 2, 3, 1, 2, missing 1. All right, let's run it. We get a range 0 through 10. Right? Well, let's subtract 1. We get a range 0 through 9. Okay, so let's put an index -1. Ah, look what it did. It flipped the index around. The range now starts at 9 and ends at -1. Okay? If we made this 0 and reran it, it would start at 9. It would go to 0. And then we can do something even more malicious. We can do a countdown. Doing the -1 subtracts 1 each time we iterate through the range. So let's go back to our function call and let's switch our -1 to 0 and then make this a -1, our countdown. Okay, and then we're going to print, okay, word I, or our index, where we're added our index. We're going to print that as our tester, okay? And so it looks like it did print from 0. But see, we have, this has to be -1. See how the C, this isn't Codecademy backwards? Because we need to include 0. And right now we're excluding 0 by calling this range at 0. This is why this has to be -1. And we run this and we get Codecademy backwards. Cool. I'm cool with that. Still not great. Still not what we want. Okay. But what we can do is take that print statement that we just did. And let's extend this so this looks so crazy. We take that print statement that we just did. And we're going to add it to new word. Okay? Literally add it. I'm going to add in the word I. Okay? And that's going to populate this string with Codecademy backwards. Okay? And we can prove that because then we're going to return new word. Okay, which is this list. It's not a list, it's a string. We're adding characters to the string. So let's run this. And there's Codecademy backwards, which is our test. And let's check our other test. And should print nothing. So this empty character string printed nothing. And then this hello world should print this statement here, which it does. So we were able to reverse the strings through some Python trickery. We're almost done. We have 2 more left. Let's set this real quick. And this is called make spoonerism. Interesting. So a spoonerism is an error in speech when the first syllables of 2 words are switched. For example, a spoonerism is made when someone says belly jeans instead of jelly beans. Interesting. Write a function called make spoonerism. So there's our requirement. That takes 2 strings, word 1 and word 2. Word 2. Okay. Finding the first syllable of a word is a difficult task, so for our function we're going to switch the first letters of each word and return 2 new words as a single string separated by space. Easy enough. We're just switching, so we're just going to switch the first letter of each word. And in order to do that, what do we have to do? We have to find the first letter of each word. Or, more importantly, we need to find every other letter except the first letter. So let's create word 1 slice and set it equal to word 1, which is our word that's coming in. And we're going to slice it from the first character to the end of the word. We're going to do the same thing for slice 2. Except word 2, I mean. We create a second slice, which we're gonna trim off the very first letter, okay, and we're just gonna grab the slices. We don't care about the first letter. Okay, and we're gonna create a phrase here. And the phrase is going to be word 2, the first character, right? Plus the word one slice, right? So remember jelly beans? That will give us belly, the word belly. Okay? Plus, I'm going to put an empty space here. Plus word one, 0. Okay? Plus word two slice. And then we're going to return the phrase that we just created. And then we're going to fix this because this looks, remember, we got to use substitution here. Hello world, Wello, World, Load Academy, CERN instead of Codecademy Learn. So it passed, but this phrase, ugh. So this phrase we're going to have to change. And the way to change this is going to be, we're going to create a string, and we're going to put in indexes. Not bad, not too difficult. We're in dot format, okay? And in the dot format, we're gonna just, I think, take word 2 dot 0 comma word 1 slice comma word 1 first position comma word 1 slice, and we're gonna get rid of this here, and we're gonna run this, and it does the same thing. Cool. So we're using the substitution. So here you can see our sentence. Here you can see each of the substitutions that are placed into here. And it looks a little bit cleaner than that huge crazy concatenation. And I actually like how that looks. It looks pretty good. All right. So last one. Come on. Last one. Let's go. Reset. All right. So very last one. Let's go. Oh man. Okay. So create a function named add exclamation. Remember to save these in your general functions folder. Add exclamation with one parameter called word. This function should add an exclamation point to the end of word until the word is 20. So we know that's a condition right there. So we know that underneath here we're going to have less than 20 at some point, right? Characters long, return just word. Okay, so this is actually a while loop. So while the length of word is less than 20, right? I'm just going to add an exclamation point to it every single time until it reaches 20. It'll loop around. It'll keep checking the length of the word. Okay? Otherwise, when that's fulfilled, when it's greater than 20, or it's equal to 20, we'll just return the word. So let's run our test. So we know Codecademy is 10, so to add 10 exclamation points. Let's print this. And this just printed out the word. It did not add any exclamation points. So we have completed our function challenges, and we did it in a timely manner. Yay, go us. All right, so let's find out what's next. It looks like we're going to have a project coming up. You will be exchanging coded communications with your pen pal. Follow the steps below to get started. So it looks like it's a Jupyter notebook problem. So we'll go ahead and explore that on the next video. I'm Jeff for Cycle 35. You guys have a great night and keep coding.